So the first problem we're going to look at for part A, it asks us to integrate a function without changing the bounds. So we're going to evaluate this using u substitution, then we're going to put everything back in terms of x, and then we're going to evaluate the function. Then in part B, we're going to do the same problem, but we're going to change the bounds. And I'm going to show you that we get the exact same answer, but method 1 is actually a lot more concise. So we're going to actually see that B, while it has an extra step in the setup, makes the actual calculations a lot simpler. So the problem is 24x to the 23 over 1 plus x to the 24th. So the obvious choice for me to pick my u is I'm going to let u be everything that's underneath that radical. So 1 plus x to the 24th. So now my du, the derivative of 1 is 0, and I get 24x to the 23rd dx. So here's my du, and my u is everything under the radical. So now when I translate this integral into my new variable, we're going to leave the bounds off using this method. So we're just going to look at evaluating the indefinite integral of u to the negative 1/2 du. So the reason I'm changing it to u to the negative 1/2 is it's just 1 over the square root of u, and it's easier for me to use the power rule using this method. So now we evaluate the indefinite integral just like we did last night. So it's u to the positive 1/2, and when I divide by 1/2, I just get 2u plus c. Now we're going to put back in what u was. So I'm going to rewrite this as a radical, 1 plus x to the 24th plus c. So now if I want to evaluate this from 1 to 0, the integral from 0 to 1 of 24x to the 23 over the square root of 1 plus x to the 24 dx, well, we have our antiderivative. It's 2 root 1 plus x to the 24th, and we evaluate that from 0 to 1. So when I plug 1 into here, I get 2 times the square root of 2, because 1 plus 1 to the 24th is 2. When I plug 0 in, it's going to cancel this out, and so I'm just going to get minus 2 times the square root of 1, and this is just 2 root 2 minus 1. Now we're going to do this again, but instead of working with the indefinite integral, we're going to deal with the definite integral. So our u is the same u we used before, and our du is 24x to the 23rd dx. Our original bounds on x are 0 to 1, but now I'm going to change the bounds. So a is 0, so when x equals 0, then what we're really saying is the new u, we just plug 0 into our equation for u. So our new u is 1. When x equals 1, well, now I plug 1 into this equation, and now my u is 2. So this integral in terms of x, now when I set it up using my u substitution, I still get u to the negative 1/2 du, but now rather than evaluating the indefinite integral, I can just plug my new bounds in. So now this is the integral from 1 to 2. So it is implied in an integral that whatever this variable is right here, that is actually u equals 2, u equals 1. So on the original integral, because this said dx, this is x equals 0, x equals 1. So if you are changing your variable to u for a definite integral and you put 0 and 1 here, it would be completely wrong and it would give you the wrong answer. So you change the variable, you change the bounds. So now when I anti-differentiate this, well, I still get 2u to the positive 1/2, but now I never have to go back to x because I have my new bounds on u, and I can do the direct substitution here. So 2 square root of 2 minus 2 square root of 1, and I get 2 root 2 minus 1. So if you look, exact same answer, but look how quick the work was here, and look at all the steps we had to do here.